All right, today we're doing a deep dive into a piece of infrastructure that, honestly, most of us never even think about until it doesn't work.
We are talking about a cable.
But not just any cable. We have the source material for the NTI DP8K-FOCMP-70M-MM. It's a 70-meter DisplayPort cable.
And let's just get this out of the way immediately. This isn't a $20 cord you grab at the checkout. We're talking about a list price of around $470.
Exactly. So that brings us to the mission of this deep dive.
Whoa.
Why? Why on earth does a single cable cost almost as much as a new gaming console?
And what problem is it solving that, a cheap copper wire can't?
It really comes down to physics, doesn't it?
Uh-huh.
The main issue being signal loss.
That's the one. It's called attenuation.
Yep.
If you take a standard copper DisplayPort cable and try to send an 8K signal through it, you're lucky if you get 5 meters, maybe 10.
Before it just turns into static or nothing.
Right. Copper just has too much resistance over that distance. But this NTI cable is rated for 70 meters. That's nearly 230 feet.
And the specs call it a hybrid active optical cable. So I assume hybrid means it's not just like pure glass fiber inside?
Correct. It's a mix. It has fiber optic cores to do the really heavy lifting. That's the video signal itself.
Because light doesn't have electrical resistance.
Precisely. That's how you get a perfect, lossless 8K signal at 60 hertz over that kind of distance. But it also has copper cores in there, too.
Which must be for power. That seems to be the key to the plug-and-play feature they mentioned. With active cables this long, don't you usually need a separate power brick?
You often do, yeah. Pure fiber can't carry electricity, so you need to power the chips at either end. By keeping those copper strands in the mix, this cable just pulls power directly from the DisplayPort source.
No extra plugs, no trying to find an outlet in a ceiling somewhere.
It just works.
So let's talk about the amount of data we're actually pushing through this. The specs say it's DisplayPort 1.4 with a bandwidth of 32.4 gigabits per second.
I mean, that is a massive pipe. It allows for things like 4K resolution at 120 hertz, or for the competitive gaming crowd, 1080p at 240 hertz.
But the really interesting detail in the documentation is actually a limitation, isn't it? The one about 8K.
Yes. The note on the Dell UltraSharp UP32 18K monitor.
That's one of the few true 8K monitors you can actually buy.
It is, and the source material is very clear. If you want to drive that specific monitor at full 8K resolution, one of these cables, well, it isn't enough.
You need 2 of them.
You have to run 2 of them in parallel.
Wow, so that's almost $1,000 in cabling just to get an image to one screen. That really puts the whole 8K future into perspective.
It just shows you that even with 32.4 GBPs, we are right at the edge of what a single connection can do.
Okay, so moving beyond pure speed, there's the safety rating. That word in the name, Plenum.
Yeah.
To the average person, that's just jargon.
But to a building contractor or an IT installer, that word determines if you pass inspection or not. It's a very strict fire code rating.
And plenum spaces are the air circulation paths in a building, right?
Yeah.
Like the space above a drop ceiling.
Exactly. And in a fire, the absolute last thing you want is for a melting plastic cable to start pumping toxic fumes into the building's air system.
So the jacket on this cable is flame retardant.
Highly flame retardant. It self-extinguishes and it doesn't produce that thick, toxic smoke. This tells you the target market isn't a home theater. It's medical facilities, airplanes, large-scale digital signage.
And those use cases, especially medical, would also explain the big emphasis on interference immunity.
That's the other superpower of fiber optics. Copper wire basically acts like an antenna. If you run it past an MRI machine, you're going to get noise in your signal.
But fiber is just carrying light. It's immune.
Completely immune to RFI and EMI. So your image stays crystal clear, even in a really noisy electrical environment.
So when you pull back and look at the whole picture, this $470 cable is a very specific industrial-grade bridge.
It is. It solves the distance problem of copper, the power problem of pure fiber, and the fire safety problem of regular PVC. It's the invisible backbone that makes it all work.
It does make you wonder, though, if we're already at a point where we need dual optical cables for a single 8K monitor today, what's the infrastructure going to look like in 5 years? When 16K or maybe even holographic displays become a thing, are we just going to need a bigger pipe?
Or maybe a new law of physics.